What I did is that I picked a document from the net, a design from the net, a simple two-bedroom
Okay.
house. Any? Do you see my screen?
Yes.
I picked a two-bedroom house from the net. Then this is what I'm going to do. Whilst we are working on it, I'll still be making some few changes to it. Okay.
Okay.
Okay. So I'll just start it and you move on from there. So I'll start a new project like we've always been doing. I think this is the third time we are going through the same process again. So at least everybody will understand the process of starting a new project from a template and then choosing, deleting, creating the level that we need for the project and then moving on from there. Okay. So I'll go to new file, new project. I'll choose metric multidiscipline, new project, and then go to OK. Now I'll go and delete all the views. So I'll go to discipline, view discipline, and then choose all views. I don't want it by discipline. Then I'll right click on the views and then expand all. And then start from the bottom, leave only the elevations, and then delete all the views. Delete everything. And leave only the elevation views. So I only have 4 elevations. I'll delete the section also. Delete the scope boxes. Delete the reference plane. Go to 3D view and check. I don't need any scope box. I'll delete the scope box. Then leave only the 2 levels. So if I go to any of the elevations, I only have 2 levels available. So I'll uncheck here, check the left, uncheck here, and then check the left one. This level 0 here, I'll call it ground level. Any project that you do, unless you've created your template, you will still go through these processes. But when you have a good template and do the proper settings, you will not be doing it. So this will be ground floor level. When I finish, I expect everybody to go through the same process. Okay. I'll give you time to practice it on your own. So I have the ground level, I have the ground floor level. The distance between ground floor and ground level, let be 600. 600 difference. I'll increase the scale to about 1 in 50 so that they don't overlap. So I can create more levels. I'll create a level. I don't want to create a plan view. I'll choose pick option, give it an offset of 900 for the foundation. And then I'll check it. And I'll give an offset of 3,150 for the room height. Then I also check this one. So I'll select all the levels, make sure that they are the same level, 8 mm level. So that this one, negative 900, will be the foundation level. This thing we've done before, that's why I don't want to go over it again. Foundation level. This is ground level, ground floor level. Then this will be roof level. But we are doing only 1-story building. Roof level. Okay. So I have my 4 levels. Now I'll go here, uncheck this one here, uncheck that one. I wish everybody too can open one of the elevations and then create their levels. Are you okay? Hello? Are you okay at this point?
Yeah, for me, I'm okay.
Yes.
So everybody can create their levels.
Yes.
Yeah.
I can.
Okay. So what are you supposed to do next?
We create the floor plans.
We create the floor plans. So that's what I'll do next. In this case, I'm going to create a foundation floor plan, the ground level, and then ground floor, and then roof level. I'll create for all of them. But only that the foundation one, I'll make it structural. And then the ground level, and then the ground floor level, and then the roof level, I'll make it normal floor plans. So I'll go to view menu, go to create panel, under plan views, I'll choose floor plan. Then within the floor plan, ground floor up to roof level, I'll select the 3 of them, architectural plan, go to OK. So when I create them, you see that I'll get floor plans here, roof level, ground floor level, and then now ground floor level. But the naming, this is a floor plan. It is not a floor level. You understand? So I'll have to rename it as ground floor plan instead of ground floor level. It's not a level. Ground floor plan. No. Then I'll rename this one also. Rename this one. And this one will be ground. And then this one is ground level rather. Yes. Or let me call it site. Ground level is site for now. I'll call this one site. CT, SIT. No. Then this one will be roof plan. Rename. Roof plan. No. So I now have the roof plan created. So I have the ground floor plan, I have the roof plan, then I have the site. It's left with the foundation, but the foundation is going to be a structural plan. So I'll go to plan views, structural plan, then I'll do foundation level, and I choose structural plan, and I'll go to OK. So you see that a structural plan is created here called foundation level, but I'll rename it as foundation layout, no plan, layout. Enter. So I now have foundation layout, I have ground floor plan, I have roof plan, then I have sites. Left with one more plan view that I need to create, a reflected ceiling plan for the ground floor, so that I can create a reflected ceiling plan whereby I can position my light fixtures and my ceiling fan or anything that will be boosted by the ceiling. So I'll go to plan views again, then choose reflected ceiling plan. And the reflected ceiling plan, I only need it for the ground floor. I don't need the reflected ceiling plan for the foundation. I don't need it for the ground level. Neither do I need it for the roof level. It's only for the ground floor level. So I'll go to OK. So you see that a ceiling plan is created, architectural ceiling plan, and it's called the ground floor level. So I'll rename it as ground floor. I'll not type the full name. I'll make it ground floor RCP, as in reflected ceiling plan. So now all my floor plans are now created. I have all my floor plans created. I have all my reflected ceiling plan created. I have my elevations with my levels, foundation level, ground floor level, and then roof level. So now I'm ready to start the modeling. So I'll go to floor plan, and then here I can draw the model straight away if I know my design that I'm doing. But because I'm going to use this design, okay, so I'm going to import this image and then draw over the what? Over the image. So I'll minimize it and then go to insert menu. If you want to bring any external file into Revit, you go to the insert menu. And when you go to the insert menu, we have link. You can link an image or you can import an image. But I'll link an image. So I'll click link image. So I'll click on that one. I'll go to the folder that contains what I want to do. So I'll open my desktop, then go to Revit Essentials Training. And within that one, I have this 2-bedroom house, thumbnails, 2-bedroom house design. Open it. And when you open it, it will come in like this one. This is just an image. This image is not scaled. It doesn't have any scale, so I need to scale it and then make it work. And I'm going to, please, it's not about it, just as time goes on, you can adjust the building so you can get proper size. And this one is just schematic. As you move along, we can be correcting it. I call it continuous improvement. So I'll take this one, select the image. Then there's a scale tool here. Under the modify panel here, you should see scale here. Scale, keyboard shortcut is RE. So I'll click on scale. Then I'll click on one point. From the internal, I'll zoom in a bit from this corner here up to this internal corner here. When I click, it's giving me approximately about 5,140. But I want it to be about 4,200. I like big rooms. I don't like small rooms. So this one is now scaled. So if I check the distance DL from this corner here to about this corner here, I'm getting about 4.2 meters. It's okay. So now that I have that, I can draw over this. And after finishing drawing over them, I can delete it and then work on the building realistically. So to draw over them, the first thing I need to do is to pick my walls first. So I'll go to architecture, go to walls, drop down menu, pick architectural walls. So I'll pick walls. The first thing I need to check that I confirm that I have the height of the wall, not the depth, the height. And I want the wall to extend to the roof level. So I'll click on roof level here. And if I check the properties, you see that the unconnected height in the properties is now 3150. So I'll start from the corner here. I'll pick a line from this corner here, come down all the way to here. Later on, I'll adjust the dimension. Don't worry about if you are not okay with the dimensions. I'll cross to this side, come all the way here. Then I'll cross to this side to give me a round rectangle. So I use lines to do this one. I can also equally pick rectangle to draw. So with the rectangle tool, I can start from this corner here, eyeballing, and then cross all the way to the back here, using eyeballing, okay, to get to this one too. So at least I have the room here defined. I have this room here also defined. I have this terrace in front here also defined. Then I have the back here defined. So what I'll do is that I can, this balcony is okay, it's just entrance terrace, but this wall here cannot go all the way to, it should rather be moved to this location here. So I'll pick another wall from this corner here to come and meet that corner up to this point. Then I will use the split tool. This modification tool, there are many of them. Try be using them. If you get any challenge with any of them, let me know. So I'll use the split tool here and then split this wall here. When I split it and I select the wall, you see that there are two drag points, one at the end here, one at the other end here. I can hold the drag point and then pull it to this wall. Or I can use the extend tool. I'll pick this extend tool, select the object I want to extend to, which is this wall. And then the side of the wall I want to extend. This one need to be extended. So if you look at it now, I now have this terrace deck defined. I have this room defined, that room defined. This room is also defined. Then this terrace at the back also defined. So what is left for me to do is to do the internal walls. So I'll come in here, select this wall again, right click, create similar. So I'll draw this wall from this corner here all the way to that corner here. Then I'll draw another wall from here to here to separate the bathroom and then the working closet. I'll come to the side here and then do the same thing. And draw another wall from here to there. I'm only eyeballing. Later on, I'll adjust the dimensions properly. Then I'll start from all the way here to here. So now I have all my walls as of now. So if I click on the image now and right click and then choose hide in view elements. Now all the elements are hidden. I can see my layout properly done. If I go to 3D view here, I should see my layout properly done also over here. Any question?
My question is, why did you link the image file instead of maybe taking it?
You can link it, you can import it, whichever option you can use that one. I have no problem with that one.
Okay.
So now I'll pause and I'll give everybody opportunity also to create your levels and at least lay out your design whilst I wait for you. Or if you think you're okay, I should continue, let me know.
I think I'm okay. I remember.
Yeah, please, I'm also okay.
Okay. Benjamin.
Okay. Can you continue?
I can continue.
Sure.
Mr. Franklin.
Yeah, please continue.
Okay, Dixon.
Yes, sir.
Are you okay? Do you want to give it a
Sure.
try?
Yeah, I'm okay.
Yeah, okay.
Yeah.
Good. So now
Yes,
up to this point,
I'll be in the other place to work on it.
okay. Okay, so now what has happened is that I've drawn my main walls. I've not drawn my foundation walls yet. So I can copy the whole of the walls here in 3-dimensional. Okay, then go to copy to clipboard. Then all the walls are now copied to clipboard. Then I'll choose the paste drop down and then choose align to selected levels. So when I choose align to selected levels, which I can paste it on the foundation level. So I'll click on the foundation level and then go to OK. Then all of them will be automatically placed on the foundation level. Whilst it is still selected, I'll go to the properties palette. You realize that the base constraint is foundation level. And then the top constraint is up to the roof level. But I want the top constraint to be ground floor level. And then I want the top offset to be what? 0. So that it will start from the foundation level with base offset of 0, terminate at the ground floor level with a top offset of 0. As soon as I move my cursor in, you realize that all the walls will start from the foundation up to the ground floor level. I can still copy this one also, copy to clipboard again, then go to paste, align to selected levels. And this time around, I'll paste it on the roof level so I can get the walls that I'll project to my roof in case I do the roof. So I'll go to OK. Then it's also pasted on the roof level. And because there are no other walls on top of the roof, the base constraint is the roof level. The top constraint, I'll make it unconnected. And then I'll give it an unconnected height of about, say, 450 for the 2 blocks of wall that will be on top of the roof. So that it is these walls that I am going to project to meet my roof should the need be. So now I've created all the walls that I need for my project. Foundation walls, ground floor walls, and then after the ground floor beam, whatever, I have my walls on top of the roof, which I can project to go and meet the roof. Remember, I am not using the walls on the ground floor to project that one to the roof. The reason why normally I do this is that when you are scheduling, at times you need to schedule and inform the client the number of blocks that the client might need for the foundation level, or the number of blocks that the client might need for the ground floor level, so that it helps you do proper estimation. But if you do it one unit and then you project that, it will be very difficult for you to advise the client as to the various stages of construction, maybe at the foundation or at the ground or at whatever level. So this is what you have right now. Now we've done the walls. The next thing that I can do is that I can begin to add my floors. So I'll go to the ground floor plan, then I can begin adding my floors. Now, when you're adding floors, one thing should concern you. Normally, if you go into a building, not all floors have the same elevations. Maybe at the terrace level here and then the terrace level here, the elevation might be different. This elevation, there might be a drop of 150, so that those floors might be drawn separately. Then internally, if they are the same elevation, then you do them one. Please, this space at the back here, it seems too small for me. I want to increase it a bit to about, say, 1,500, so that to be a bit spacious, or let's say 1,800, so that to be a bit spacious. At the back, 1,800. So now I can begin to add my floor. So I'll go to architecture menu, pick floor, architectural floor. Then I can use lines to draw my floor. I can use, and you understand whatever you are doing, we are going to model it that same way, so it works the way we want it to be. Thank you for the question. You will do that. Right now, we're only learning how to draw the walls, how to create the floor, how to create the ceilings. Later on, we are going to edit them for them to mimic real conditions.
Okay, sir. Thank you.
Thank you. So now I can go to 3D, delete these two rows. I don't need them. They are done. Now, I have a fair idea of how my building is going to look like. The next thing that I'm going to do is I'll go to the ground floor and then add spaces to them. That is, add rooms to them. So I know that this one is a bedroom, this one is a living room, this one is whatever. So I'll go to architecture menu, go to rooms, drop down, and then choose room. When I choose room, I can place the rooms manually, room 1, room 2, room 3, room 4. But it's a lot of waste of time. We have a tool called place rooms automatically. So I'll click on that one. Then Revit will automatically create all the rooms for me one time with their names and their numbers. The only thing that I need to do is to give the rooms what? Names. So I'll select this room here. If I go to the properties, I'll see room name here. I can change it and then type in the bedroom. Or I can click on this name here and type bedroom. Whichever is convenient for you, can adopt that. So I'll go to cap log, bedroom. I'll come in, call this one terrace or porch. I'll call this one living room. This one is also bedroom. Because I've typed the bedroom already, if I select this room, and I go to the name here, and I choose the name drop down, I should see the bedroom there. I can click on it. Sorry. Then we have this bedroom here. So the back here will also be another terrace. This one here is bathroom. So I'll call it bath. This one here is working closet. WIC. WIC. Then this one too will be WIC. This one is not WIC, it's rather bath. So I can change it to bath. So I've labeled all my rooms now. The next thing that I want to do is that I can add grade to my work. So I'll add grade lines. So I'll go to architecture. Then I'll go to day 2. And then look for grade. So I'll click on grade here. When I click on grade, I can come in here and then click my grade from here to there. Grade 1. I can adjust it to the top. Check it so that I have grade 1 there. When I'm done, I can copy it. I will not add grade to this internal one. Let's take this grade, copy, CO for copy. From here, I'll bring it here. So I'll get grade 2, grade 3, and then grade what? Grade 4. Now I need to add horizontal grade also. So I'll go to architecture again, choose grade, then come horizontally, and then draw this grade. I want the ABCD to start from the top. So I rather move it, MV. Move it from here to here. Then rename this grade as grade A. I'll check here to make sure that it's also what? Grade A. Then when I'm done, I'll copy it. CO for copy. I'll copy from here to there, to here, to here, to here, and then to there. So if I see, I now have my what? All my grades drawn. So I'll adjust this grade down a bit. They all move together. I'll adjust this one to down a bit. They all move together. So I have this grade line too. I'll adjust this one to the right a bit. I'm going to show you how you can make it uniformly drawn. But for now, just use eyeballing to do that. So I have my grade set. So if I go to the elevation south, my grades are there. I can adjust it up a bit. Then I can adjust it down a bit. I'll go to the west elevation, adjust it up a bit. Then adjust it down a bit. Now, if I go to the east, I'm okay here. If I go to the west, I'm okay here. If I go to the north too, I'm okay here. So now I've created all my grades. I've created my levels. I've created my system elements. I have a building. Any question?
Sir, Senior.
Yes, sir.
Yeah, good evening. All.
Good evening, boss.
Yes, sir. I want to ask a question.
Yes, sir, ask.
I want to ask, did you, for now, you draw the plan, you draw the ground floor plan, the roofing plan, everything before putting on the grid on the plan. So is it necessary that you can draw the grid on the plan before doing the roof and everything?
Yes, you can do that. That is especially if you know you are great already. Maybe, for instance, you are doing a commercial property, some shops, and you know that all the shops are going to have regular intervals of, say, 3 meters, 3 meters, or 3.6 meters, or 3.6 meters. Then you can draw your grid layout. Then when you draw the grid layout, then you can draw the walls over them. You can also do that. Let me illustrate for you to see. For instance, I can come to the side here, go to architecture, take a grid, draw grade 1. You understand? Draw grade 2. Draw grade 3. Draw grade what? 4. Draw grade 5. So I have 5 grades. Then I can draw another grid here. And draw another grid here. I can draw another grid here. Then I can check and make sure that the grids are properly spaced. When I select this one, I can get the spacing between them. But that's not what I'm interested in. I'm interested in you drawing the grid first. When you are done with it, then you can go and pick your wall, and then draw over the wall, over the grid. Maybe from here to here, go here, come in here, go all the way, come down here, go all the way to here, go there, and then come back here. The discretion is yours. Whichever way you work, that will make life bearable for you.
Okay.
So I can draw.
But is it possible to, after drawing this grade, you can put in the windows and the doors before you do the other?
Yes, sir, you can do that.
I'm asking, is it possible that as you have done you have done the grade, and you have put the wall around it, can you put in the doors and the windows before doing the floor plan, ground floor, ground level, the roof? Okay.
Yes, sir.
Thank you.
So long as you've drawn the wall, even if you draw one wall, I can delete all the walls here. And then just draw one wall. If I know that between this one wall, I need one window here and one door here, I can go and pick my window, okay, and put it inside. I can go and pick my door. So long as there's a wall, I can pick it and then put it inside. Nothing constrains me. But from my experience, what I recommend is, when I'm modeling, I prefer to get the form of the building first.
Okay.
The form of the building, defined by the walls, the roof, the floors. So I know that. So now, if you look at what I have here, you see that I have a complete idea of how the building is going to look like.
Yes.
Although it's not detailed.
Yeah.
Then when it is done this way, that is when I'll come back and begin to start editing it, adding doors, adding windows, adding columns, adding those things. But you must develop a workflow that is convenient for yourself. Yes. And as you continue to work on several projects now, you will get a workflow that is convenient.
Thank you.
Yes, sir. Any question again? So I can delete these grades. Any question?
No, I'm okay.
Okay. Who has an issue? So I can proceed, or you want to practice? Tell me, who is singing? We mean business, so I beg. Should I give you time for you to practice?
Yes, please.
Okay, so you have about 5 minutes. Practice. If you have issues, then we address them.
Say,
Yes, sir.
do you want us to practice as you are teaching? I thought maybe you finish them tomorrow in the morning. Maybe if we are in the office, you can practice it before in the evening.
Okay, then let's continue. So no question.
If somebody wants to practice before we continue, fine.
But I think let's continue. If you have question, ask. Then when you close, you can practice. Then when you meet tomorrow, then you have a question, then you bring it up. If you don't understand, you can go over the video again and then watch it again.
So that means you are recording it, you will send it to us.
Yes, sir. I'm recording.
Thank you. Thank you.
Yes, sir. So now that we've done this one, the next thing that I want to do is that I want to prepare my views so that I can put them on sheets. Most of the time, most people will waste their time modeling and not preparing the views, the deliverables, what they're going to deliver at the end of it. And when it is time for them to print, then you see them hustling. So me, when I get a form like this, the next thing that I do is that I make sure that I prepare all the sheets that I need, prepare all the views that I need, and then put them on the what? On the sheet. So that I know that I'm working with 6 sheets, I'm working with 10 sheets, I'm working with 20 sheets. Then later on, I'll come back and start fine-tuning the model. Any changes that I make to the model, all of them will be updated on the what? On the sheet. So that's what I'm going to do next. I'll go to the ground floor plan. There is a tool here called crop view. Here. Crop view. And then show crop region. Now the show crop region is off. Let me turn it on. When I turn it on, you see that there's this show crop region here. I can adjust it to the edge of the grid.
Sir.
Yes, sir.
The crop view that you are saying, which place do you pick from?
If you go to the view controls here.
Under it.
Yes. And under the view on the right, where you see the scale, you see there's a scale here. Do you see?
I understand.
When you go there, you should see a crop view there.
Okay.
And then the next to it, there is show or hide crop also there. So I'll make sure that the show crop is active. If I click hide, it will go. If I click it again, it will come back. Do you see? Now, if you also go to the properties on the right, we have it here, crop region visible, crop region visible. So you can click it off, okay? Then you can click it what? On. Do you see it? So I'll make sure that I'll go to the properties and the extent, look for crop region visible, then check it or uncheck it. Now, if I check it, it will show. So I want it checked so that I can see the crop. When you do that, then if you can select the crop, and when you select it, you see that there are 4 dots on the 4 sides. So you can hold the dot, increase the crop, or decrease the what? Crop. So normally I want it close to the building. But this method is very laborious. I will not recommend anybody to do this one. When you're doing it this way, it means you must also go to the roof plan. You understand? If you go to the roof plan, then you have to come back and then switch it on again to see it, and then adjust it manually, and come back here and then adjust it manually. Now, if the building is about 12-story building, 12 stories, then it means that you have to go to all the floors. Ground floor, adjust. Second floor, third floor, 8th floor, 13th floor. It's waste of time. It doesn't help. There's a shortcut that you can use to do it, and we call it scope box. Scope box. You can use the scope box to scope the project. So let me show you how to do that. You go to view menu. You go to view menu. Then within the view menu, under create, you should see scope box here. Do you see it? Scope box. Nico?
Yeah, I've seen it.
You've seen it? Good.
Yes.
Take this scope box and then draw a box around the building like this one, so that the building will fall within the what? Within the box. If you go to 3D view, you should see that box. This is the box. We call it a scope box. If I look at it from the front, you see this is the box that I've drawn. If I select it, it is way above the building. But I want the box to go below the what? Building. And then come down to the top of the building like this. Adjust it to the side like this one. This way. So I see that the building is falling within the what? In that box. I can go to the side also and then make sure that the building falls completely within the what? Within the box. If I go to the top, the building is within that particular what? Box. If the building is big, you can make the box big. If the building is small, you can make the box what? Small. We call it a scope box. So you make sure that you draw the box and fit the building within the what? Within the box. Any question up to this point? Scope box. To create it, you go to one of the floor plans, you go to the create view menu, create, and then look for scope box. You click on the scope box, then you draw a box around the building like I did. Let me remove the crop region, hide. And then let me do not crop. And then draw the box like this one. Have you seen it? This is the box. Now, if you go to 3D view, you see the box like that one. When you create it, you select the box and then give it a name. You say there's a name here. By default, it is calling it Scope Box 3. I want to call it General Arrangement. General Arrangement. General Arrangement. So whether I'm creating a plan, whether I'm creating a reflected ceiling plan, elevation, section, anything, it will be within this what? This box. That's why I'm calling it a scope box by the name General what? Arrangement. Now, when you finish creating the scope box. The next thing you need to do that if you go to the ground floor, like this one, you go to the view under extent here. Under extent, you see the scope box here. Currently, it reads none. So if you click on the none, you see a drop-down arrow. Then the general arrangement that I created, you can see it here. Then select it, general arrangement. As soon as you bring the box in, Revit will automatically crop the view to the extent of the width of the scope box. Neat work. When I go to the roof plan, I don't need to go and crop manually. The scope box is already there. So I'll just go to the properties extent, scope box, assign it, and then go to general arrangement, then to crop it. When I go to the south elevation also, you see that it's big. I'm not going to select this view and then manually adjust this one and adjust this one. It is a waste of time. So I'll just go to the scope box and then select it. Then it automatically crop it within that box for me. I can select all the 4 elevations at a time. All the 4 elevations at a time. When I select it all together and I go to the scope box, it reads varies. I'll select the drop down and make sure that all of them is assigned general arrangement, sharp. So if I go to the east elevation, properly cropped. If I go to the north elevation, properly cropped. If I go to the west elevation, properly cropped. The second ceiling plan, I'll select it, then that one too, I'll assign it scope box. Please, in any project, you can use more than one scope box. Depending upon what you want to show, then you draw a scope box for that particular area and then use it. As time goes on, I'll show you how and when you have to use the scope box. So I'm done. So now all my floor plans are properly cropped. All my elevations are properly cropped. Now, what I need is I need some sections. So I'll go to my ground floor plan, then I'll draw some few sections. So I'll draw first section through the side here. The next section, create similar through the middle here. The third section, I'll select it again, create similar. And then draw another section also here. 3 sections, vertical. Then I'll draw another section horizontal. So right click, create similar, another section from here to here. Right click, create similar, another section from here to here. Right click, create similar, another section from here to there. So I have 4 sections. I'll select all the sections, select one of the sections, right click, select in the entire project. So you see that all the sections are selected. If I go to filter, I'll see that I have all the sections selected. Then I'll go to scope box. And I'll assign the scope box general arrangement to them. So if I open this session, it falls within the scope box. If I open any of them, it also falls within the word scope box. So now I have all my sections already created. The next thing that I need to do is create my sheet and then populate my sheet with the sections, elevations, floor plans that I've created. So that's what I'm supposed to do next.
So in that case, can we create the elevations to in scope box?
Yes, we've already done that. I selected all the elevations and placed them in the scope box. So east elevation, the scope box is already assigned general arrangement. West elevation is assigned general arrangement. I've done that already.
All right. Thanks very much.
So the next thing I need to do is to create my sheets and then put.
Sir,
Yes, sir.
why do we do this? Why do we create the scope box?
Do you understand scope?
No,
The word scope.
no.
Please, who can help us with the meaning of the word scope? Scoping. To scope something. Scope. Scoping means defining your limits or your boundaries within which you are working. Okay? When you say scoping, what scoping means is that you are defining the boundaries within which you are working. So when you are working on a building, you see, if you look at this building in three-dimensional, the building has its extent. We call it extent. That's the word here, extent, in the properties here. Extent. So you have to define which aspect of the building that you want to show. So we do the general arrangement to show all the building in complete, the whole building. So you draw a scope box to define the range within which the building will fall. So you do that box and you give the box a name. And then any view that you create that you want to fall within that scope, then you do that, even including the grid. Let me show you something. Look at the ground floor. When I select all the grid lines, for instance, right-click, select all instances in the entire project. So all the grid lines are now selected. Then there's a scope box and it's none. So I'll choose that one too and then make it what? General arrangement. You see that all the grids are now properly constrained with the what? With the scope box. So if you go to the elevation, you see that all the grids have been assigned to a scope box. Are you okay?
Sir, please, can you go to the ground plan? Ground floor plan.
Okay. I'm there.
I've seen the scope board around it.
Yes.
But the grid lines are outside the scope box.
Yes. Normally, if you draw a grid line,
we are working in the range of the scope box. But the grid lines and the section lines are all over the scope box.
Yes.
So without the scope box, we can't do the scope box. Does it mean something? Or without the scope box, we can't do the plan. We can't do the ground floor plan.
You can work without the scope box.
Okay.
You can work without the scope box without using it at all. I know so many Revit users who have not even used scope box before. They don't use it at all. But it is a smart tool that helps you in scoping your work. That's what I'm introducing to you early. As we move along, you get comfortable with it.
Okay.
So now I have my floor plans, I have my roof plan, I have my reflected ceiling plan, I have my elevations. So the next thing that I need to do is to create my sheets, so that I can put all the floor plans on those sheets. So what I'll do
does it affect the three-dimensional
the scope box?
Affect the
No,
scope, yes.
it doesn't affect it. It's just a box. It doesn't affect the model at all. So for instance, if I go to the ground floor and I take a camera shot, let's say from here to there, then I have a 3D view like this one. This is a 3D view showing my building. the ability to, you see, there's a scope box here. You can assign the scope box to it also if you want to. In that case, it will crop it up to a certain point. It will use the session box to do the scope box also for you. So that if there's anything outside the box, and it will not be what displayed. Yes, it's applied to the 3D.
I think I'm okay.
Let's say I want to show only maybe the living area, the living room. I want to show only the living room. Okay. So what I can do is that I can introduce another scope box. Okay. And then draw that particular scope box around the living area only, like this one. You understand? I'll draw this one. Then I'll select this scope box and then give it a name and then call it living room. Living room. So that is the new name of this scope box. So if I go to the 3-dimensional view that I just created, 3D view 1, instead of me assigning scope box general arrangement, I can choose the new scope box called what? Living room. And when I select it, you see, it will crop it only to the what? To the living room. There are different use cases for scope box. As time goes on, I'll show you how you use it properly. So if I go to 3D, you see that that's the scope box that I just did for the living room. Do you realize it? I can bring it down. Then I can bring it down a bit. So if you look at the 3D view, then you see that this is the scope box defining the living room. It helps you to define some box region within your building that you can display the way you want it displayed. Maybe you want to do some 3D live section of it. It becomes very, very useful to use it. Sorry. Are you okay?
Yeah, I'm okay.
Thank you, sir. Now, the next thing I need to do is to create my sheets. By default, there are some sheets in Revit already. What I'm going to do is that I'm going to delete all of them. Okay? I'm deleting all the sheets. I don't want to leave any sheet so that we start from scratch.
Sir, the sheet, sir.
Mm-hmm.
The sheet. Where did you find it, and where did you find it?
Me,
where did you went?
The first class.
Yes, I am.
The first class we did.
Yes.
I went over it as and in the project browser, I said that there are 7 items. Legend, schedules and quantities, sheets, families, groups. So the sheets are here.
I understand that. I understand that. If you went to the project browser, you picked it up there.
Now, if you go to sheets, I've deleted all the sheets. So there's not a single sheet here. You understand? There's no plus next to the sheet. So what I'm going to do is that I'll click on the sheets, right click, and then choose new word, new sheet, new sheet. When I click on new sheet, I'll be required to select a sheet I want. And then the title block I want. So I want to use A1 metric sheet, A1 sheet. And I go to OK. As soon as I go to OK, Revit will create a new sheet for me, which is A1 what? A1 sheet. This one is shipped by default to the software. Later on, I'm going to show you how you can create your own what? Your own sheet, but not today, maybe another day. But I'll show you how to do that. So now a new sheet is created with a title blog on it. You can see the company logo of Autodesk, their address, consultant details, revision, client name, project name, project number, date, author, drum bar, check bar, and so on. And then the sheet number. So if you check this sheet number you see here, C102, that's the same sheet number you see in the sheet here. Then the name is unnamed. Then this one too is unnamed. So I'll right click on this sheet and then choose rename. When I choose rename, I can give the sheet a number and then a name. Every sheet that you create must be given a unique number and then a unique what? Name. So for instance, I can call this one A-100. That's the sheet number. Then the sheet name, I can call it general arrangement. Or I can call it floor plans, or I can call it elevation. Then for now, let me call it general arrangement. General arrangement. So I've created only one sheet now. And it has a number and then a name. So I'll go to OK. So realize that the sheet name is now reflected, general arrangement, and then the sheet number is also here, sheet number. Later you can edit the date, you can edit the drum by, you can edit the check by, you can edit the client name, you can edit the project name. But for now, let's focus on just the sheet number and then the sheet name. When I create a sheet like this one, I can go to sheet again, then create another sheet and right click new sheet and then create a new sheet. But for now, let's work with this one. When you create a sheet like this one, you can then go to the views. And the views that you have created, you just drag it, ground floor plan. You drag it from here. Then you can put it on the sheet and drop it. So you see it will come. Then I put it here. So I'll get my ground floor plan on the sheet, as simple as that. It will come with the name, ground floor plan, the scale 1/100. Then the view number, you have it here. If I want the elevation, I can drag it. South elevation, drag it. Come and position it. Then I'll put it here. If I want the west elevation, I'll drag it. Come and put it there.
Sir,
Yes, sir.
yeah. As you said, the scale, you said the sheet is A1.
A0.
The sheet, not the
sheet is A1. Yes, sir, A1.
The sheet A1.
Yes,
but when you drag the ground floor plan and you put it on it, can it fit on the paper? Or when you're printing it, you may say, like you may click on fit to paper, or you do something to fit on the paper.
No, you can't fit on paper. Anytime you put a view on a sheet, you will decide the scale at which you want it printed.
Okay.
So when you put it here, currently, the scale is what? 1/100. So I can change it and say, I want it to be 1/50. So I'll go to the scale here, then change it to 1/50. And as soon as I change to 1/50, so that the drawing will become what? Big. on the sheet. So I can
Okay.
put this one on the side, put this one on the side here, then reposition this one. So you see that at 1 in 50, the ground floor plan is covering the whole what? Sheet.
That's it. Okay. Okay.
If I want it 1 in 200 as in block plan, I can select it, go to the scale, and then change the scale to what? 1 in what? 200. As soon as I make it 1 in 200, then it becomes smaller. Then I can position it in the sheet.
Okay. Okay. Okay.
Now, when you are putting any view on a sheet, one thing that should concern you importantly is the scale.
Okay.
So depending upon the sheet size that you are using, maybe you might be using A4 sheets, or you are using A2 sheets, or you are using A2 sheets. So the sheet you are using is one, important, the sheet size is important. And then two, when you put a view on the sheet, that view must, I repeat, must always be what? Scaled. So you have to decide that this view that I am putting on this sheet, I want it in a scale of 1 in 50. I want it in a scale of 1 in what? 100. Or I want it in a scale of 1 in 250.
So let's say we are using a one sheet, and the drawing that the graph that I put it on it doesn't fit on it. It's 1 in 100. Doesn't fit on it. You can scale it to 1 in 50.
Yes, sir.
So it fit on it.
Yes, sir.
Thank
Or
you,
you can
thank you.
scale it to 1 in 200 so that to fit on it. But
Okay. Or you can change the A1
and
to
choose a
A3
different
or
sheet.
okay.
So
Thank
normally, when you are working, the sheet that you are going to use to print is very important. So you know that the work I'm doing, I'm going to print it on A3. I'm going to print it on A2. I'm going to print it on A0. Then after that, you bring your view on the sheet. Then when you bring the view, then you decide that this view I am putting on this sheet, I want it printed at this what? This scale. It's unfortunate most of us are stick to just 1 in 100 and then 1 in 200 for block plan. No, you shouldn't be restricted because as we move along, we have general arrangement drawings, we have detailed drawings, and even with the detailed drawings, we have enlarged views, we have component details, we have assembly details, we have subcomponent details. So depending upon the kind of view that you are putting on the sheet, that will determine the scale at which you are going to put it on that sheet. Are you on the same page? Hello?
Yeah. I'm okay.
Yeah, okay.
Sam with you.
Okay. Now, depending upon the project you are working on, and then the size of sheet that is available to you, for all you know, you only have an A3 printer in your house. And most architecture firms currently working in Ghana, I don't know why it has become the standard. Most architecture firms print all their works on what? A3, without bothering the scale that they put it on. Some people can even set up their work in the drawing in AutoCAD and then put it on an A2 sheet whilst they are drawing. Then when they finish the drawing, then they scale the drawing down and then print it on what? A3. That is architectural galamsey. It is not proper. It is criminal, but we do it in this country. If your sheet that is available to you, if your printer that is available to you is A3 printer, then you must set up your drawings properly and then do the right scales and then do appropriate enlargements, call out views to detail what you want to detail. But you cannot put a drawing on a sheet, knowing very well that this drawing is 1 in 200. Then you come and tell me it is 1 in 100. And people do that. I've seen that a lot. And please, Revit will not allow you to do such a thing. It doesn't allow. Any question? Mr. Franklin? Fire.
Yeah, I'm okay.
You are with us. Cool. Gary.
Yeah, mankind.
Yes, sir.
Mankind.
Yes, are you with us?
Yeah, I'm with you.
Okay.
Yeah, I'm with you.
Yes, sir.
Yes.
So most of the time, advisably, you must know the sheets that are available to you. You must know the sheets that are available to you. And then you design your title block for those sheets and then plan your project according to that sheet. Currently, the sheet that I'm using here is A1 sheet. I can load A2 sheet. I can load A3 sheet. Later on, I'll show you how to design your own title block for A3, for A2, for A4, for A1. So that at any point in time, you can decide which of the sheets you want to work with. But apart from deciding on the title block that you want to work with, the next important thing that should concern you is that the view that you are putting on the sheet, at what scale do you want it? Currently, this scale of 1 in 200 on this sheet will not help me. So what I'm going to do is that I'll take this view and then change the scale from 1 in 200 to 1 in what? 100, so that I can position it well on it like this one. So I can have my ground floor plan on it. The same way I can take my roof plan, drag it, and I come and put my roof plan by the side. And the roof plan too will also have a scale of what? 1 in what? 100. Now, I have only one sheet. I can create another sheet again. I can create 2 sheets, 3 sheets, 4 sheets, 10 sheets. Depending upon the project documentation requirements, you can have 15 sheets, 25 sheets, 30 sheets, 50 sheets on a project. There is no standard that when you are working on any project, you must produce 11 sheets or 12 sheets. No. No. Somebody will produce only architectural floor plans. That person will not produce a reflected ceiling plan sheet. And at the end of the day, you give a drawing to a client. You don't produce reflected ceiling plan sheet to the client. Meanwhile, the client is going to make a ceiling. And as an architect, you didn't provide them with a reflected ceiling plan. At the end of the day, the client will have to depend upon artisans who will decide on where to put their lighting fixtures for them. And I don't think that is very professional. But I don't know, in this country, we see it as normal. But ideally, it is not normal. It is the duty of the architect to produce the appropriate drawings for every artisan who will work on the project. So if you don't produce a drawing for an artisan, let's say a tiler, and you go to the site, and then the tiler uses her own discretion to put the tiles anywhere, you have no moral right to condemn whatever the tiler has done. Take note of that. So now I'll create another sheet and then put in my elevations on it. This sheet that I created, currently, I only have ground floor plan and the roof plan on it. So there's no need for me to call it general arrangement. I must call it appropriate name. So I can call it floor plans instead of calling it general what? Arrangement. So I'll right click and then rename it. And instead of calling general arrangement, I'll call it floor plans. Floor plans. Then go to OK. Take note, sheet name and view name are two different things. I've seen people referring to sheet as ground floor plan, but that is not proper. You cannot call a sheet title ground floor plan. Then you come back to the view tool and then call the view tool ground floor plan. We will look at these things as we move along. So now I'll create another sheet. Right click, new sheet, A1 metric. So new sheet is created, A-101, rename it. And then call it building elevations. Building elevations. So this is another sheet called building elevations. So I can then drag the south elevation. It's already, the south elevation is on one sheet already. Yes. It's here. You see, it's here. But I don't need it there. So I'll come to floor plan and take the south elevation, drag it from this sheet and bring it here. You cannot plate the same view on two different sheets. Revit will not allow you. So I'll take the south, the west elevation tool, bring it here. Take the north elevation tool, bring it here. And then take the west elevation, east elevation tool, bring it here. So now I have all my elevations on one sheet. If you check, this elevation has a different scale from this one. And it has a different scale from this one. This one is 1 in 100. This one is 1 in 100. This one is 1 in 100. And this particular one is 1 in what? 50. So I'll select it and then change the scale for this one to be 1 in what? 100. So that they'll all be what? Uniform, like this one. 1 in 100 scale. Okay. So I now have all my 4 elevations on one sheet. Later on, I'll rearrange them for the presentation to look nice, but at least I have them on the sheet. The next one is that I can create another sheet for sections. So right click, new sheet, A1. Okay. So a new sheet is created. I'll right click, rename it, and call it building sections. Building sections. Then go to OK. So my building sections are now created. Sheet. Then I'll take my section 1, drag it. Building section 1. Section 2, drag it. Building section 2. Section 3, drag it. Building section 3. Let me adjust it to the left a bit. Okay. Section 4, drag it. Building section 4. Building section 5. Building section 6. I am randomly placing them on it. Later on, I can rearrange them. Now, the next thing that I want to do is that I want to do a schedules for my walls. So that, for instance, when I go to my floor plans here, this sheet, this ground floor plan that I've done here, I want to know the walls that I'm working with. So I can do a schedule for them. So I'll go to view menu, go to schedules, then choose schedule and quantities. I want wall schedules, so I'll look for walls. Back. Let me check the existing schedules if there is already not a wall schedule. Wall schedule. Okay, there's no wall schedule. Or better still, let me delete all the schedules here so you don't get confused. I'll delete everything. So that there's no schedule. So I right click, new schedule and quantities. Then I'll choose wall schedule. So you see that the name will be here, wall schedule. Then I'll go to OK. So with the wall schedule, I want to know the type mark for the wall. I want to know the type of wall it is. I want to know the width of the wall. Then I want to know the description for the wall. Description for the wall. When I do that, then I go to, I want to know the length for the wall. The length. Then I want to know the area for the wall. There are so many properties about the wall I can add. The volume, the manufacturer, the interior angle, the family, and so on. Let me add the family too, the family of the wall. Now go to OK. Then to create the schedule of all the walls that are available to me, I can close it and then drag the wall schedule. I'll open the schedule, wall schedule, and then drag it. Then come and put the wall schedule on a sheet as this one. I can break it and then adjust it. Break this one too, and then adjust it. So I can get all my schedules on a sheet for the walls. But if you look at it, it is repeating the same walls over and over and over again. You understand? There is a tool that you can use to format the schedule. So if I go to the wall schedule here, if I select it, and I go to sorting and grouping, so I can sort the wall. I can sort the wall by the type of wall. And then when I sort by the type, and I say I don't want to itemize every instance, I'll just uncheck this one. You look at schedules later on, then go to OK. It will show you that there is only one type of wall that we are having here. Generic wall. Okay, so here that we have the type mark is G06, the type is generic, the width is this one, the description is here, the length varies, area varies, and the family is basic wall. This one, I don't need this one again, so I can drag this one, I can select this one, then you see some small rectangle, put it on top of this one again. Then to match, you select this one to put it on top of this one. Then to match. So this is the wall here. So we have this wall type that is inside. It is a generic with a description. If I want to know the length of each of the individual walls, I can go to the schedule again, wall schedule, sorting and grouping. But please don't get confused. We look at it later on. That is the way we are going to work in future. But I want you to know that something like this is possible that we are going to do. So I'll come in here, go to the, apart from the type, I want to sort by, let's say, I want to sort by, let's say, the length. Then if I go to the length, and I go to OK, then you see all the walls with different lengths. So you see that this one, the length of this one is 2,000, the length of this wall is that, the length of this wall is that, and you can see all of them. And I can calculate the total length of wall that is available to me. You understand? Are you okay? Now, the next thing I want to do is that I've also placed rooms here. So I can do a, yes, sir.
I want to ask,
yes, sir.
The work schedules, is it necessary to be done?
Yes.
So that means if you draw the plan and you don't do the schedule, it won't be right, or it's still like, is it compulsory, or is it necessary to do the wall schedule?
You see, what we are doing, we call it a building information model. any building that you have done, let's say this 3D model that you have done here, okay, you can do a schedule for the walls. You can do a schedule for the slab. You can do a schedule for the roof. You can do schedules for windows. You can do schedule for railings. Any 3D object, if you put in lighting, you can do a schedule for the lighting. But unfortunately, because of where we are coming from, the AutoCAD base we are doing, when we do a design, most of the time, we only do a schedule for doors and windows only. So we do it, we have door and window schedule. But doors and windows are not the only components within a building. There are walls, there are floors, there are railings, there are stairs, there are ceilings, switches, socket, roof, fascia, trusses, purlins. So any 3D dimensional object that is within your model, you can do a schedule for it. That's the point I want to make.
And I'm asking, is it compulsory that when you are doing a Revit, and when you are using Revit to draw a plan, is it compulsory that you have to entail, you have to put in the schedules of everything?
Okay, can I ask you a question?
Yeah.
Can I ask you a question?
Yeah, I'm listening.
Why do we do a schedule?
I know we do a schedule to know the type of doors, let's say doors and windows, the height of it, number of it, the width of it, the thickness of it. That's the reason why we do it, right? But I'm asking that we only do windows and doors, right? But is it compulsory that we do the wall and as you are saying, we should do all this thing before we print it out, or it's not compulsory, but if you want, you can put it in.
It's not compulsory. But you, for instance, that you are a builder, that you build houses, it will be advisable for you to do a schedule for almost everything. So that if you want to do filling, let's say if you want to do filling of the building, you've done the foundation of the design, then you want to know how many trays of sand do you need to do the filling for the foundation. You don't have to let the laborers or the masons on site to come and tell you that you need 4 trips or you need 5 trips. You can do a schedule for the filling and then know how many volumes of sand you need to do the filling. So you can use it to do your calculations and then order it appropriately so that you don't order something which is less or which is what? Which is more. So normally we do the schedule. It's an analytical tool that you use in a project to manage a project, to see the numbers, to see the volumes, to see the areas, to see everything. So if I'm coming to do a fascia for maybe my roof, I need to know the total length of fascia that I will need before I'll go and buy them. You understand? Within the Revit software, you can do a schedule for the fascia and then calculate the total length of the fascia that you need before you even go to the site to go and buy it. But currently, what we do in Ghana here, we don't calculate them. We do the drawings, then after me doing my design, then I'll go and give my drawings to the quantity surveyor for the quantity surveyor to do manual takeoff to come and tell me the length of fascia that I need. Whereas I can use the computer to generate that information.
Right, sir.
Let me give an example. Me and my boss were working on a project in Tema, the Maritime Hospital in Tema. I don't know whether you know of that project.
No.
Yes, there's a project in Tema for Ghana Shipping Authority. It's called Maritime Hospital. The project was being done by Chinese. And we were supposed to do marble cladding, stone marble cladding on the facade for the whole building. So when the Chinese did the estimates and brought the estimates to my boss being an experienced man who has worked on several projects, doubted the values that the Chinese presented to him. Okay, so he called me down. These values that the guys are presenting to me for this manual, I'm not too sure because I guess they've overinflated the values. So what can you do about it? Okay, so they say, let me go and model the whole cladding for the building and then do a schedule and then find out the total area that is supposed to be used for the cladding. So I went and then modeled it. When I finished the model, we needed about 5,800 and something square meters. 5,800, less than 6,000 square meters. Do you understand? Do you know the value the Chinese submitted? It was about 18,000 square meters, more than triple. More than triple the volume. Meanwhile, this marble was very, very, very what? Expensive. So assuming that you are going to do a cladding and you need 6,000 square meters, and the contractor submit to you that the cladding is going to be about 18,000 square meters, more than triple, then the person is going to cheat on you and then take your money and then go away. But if you're able to do your schedule and then know the total area of cladding you need, the volume of concrete you need, the number of blocks you need, the number of paint of bucket you need to paint the building, then nobody can steal from you.
Okay.
That is why in Ghana here, we will do a project and say that the project will cost 30 million. And when we start the construction, we will do variation. By the time we are done with the project, then the project is costing about 120 million Ghana cedi. Meanwhile, when we did the initial estimate, we said that it was what? 30 million Ghana cedis. Who pay for that extra 90 million Ghana cedis? And that is the very reason why most projects in Ghana always do not get what? Completed. And we get to a certain point, then we chop all the money because we don't do the right thing.
I understand you, sir.
So please, this schedule thing, don't you ever underestimate it. You were not maybe doing it in AutoCAD, but I'm going to show you how you can do it in what? In Revit, so that you can schedule your floors to know the volume of floors you need. You can schedule your roof to know the total area of roofing sheet that you need. You do not have to allow somebody, an artisan, who is working with a roofing company to come to your site and measure your roof and tell you that this is the total area of roof that you need. If you do, that's what we do in the country. And it is very, 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 very unprofessional. Very unprofessional.
Okay, sir.
Thank you, sir. Any question? Any question? Nico? Antoinette?
Yeah, man, I'm here. Yeah.
Any question?
No, I don't have any question. Just like, but asking in the form of contribution, just as we need schedules for doors and windows as we've been doing, and as we know, I think you are right. We need schedules for almost everything.
Yes. If you have railings in it, you have to be able to do schedules for your railing. If you have sun shading device, you have to be able to do schedules for your sun shading device. All the building components that are within your building, you must be in a position to do schedules for them. But because we are working in AutoCAD days and we're doing line work, you know, it was a lot of work, so we were not doing them. But with Revit, it becomes easier and simple for you to do all of them. Provided you've modeled it, you can always do a schedule for it. For instance, let me calculate the total surface area of the roof that we've just constructed and show you something, okay? Let me just show you the roof that we've done. This roof here, and then this roof. Let me calculate the area for you, then we'll close. Then we'll continue tomorrow. So I'll go to schedules again. New schedule and quantity. And I want to do schedule for what? Roof. So I'll come for roof and select roofs. So I'll do a roof schedule and then go to OK. So with the roof, I want to know the area for the roof. I want to know for instance, the name for the type of roof that I'm using. I want to know for instance, the base level for the roof. And I want to know the, let's say, I have area, I have the type and base level. Let me go to OK. So you see that it is telling me that there are 3 roofs. The first one is 181 square meter. The second one is 47 square meter. And then the third one is what? Also 47 what? Square meter. If I go to formatting, I can go to sorting and grouping and then calculate the grand total and then go to OK. As soon as I go to OK and I go to formatting and then take the area, then I say calculate totals. No calculation, then do calculate totals and then go to OK. I know that the total area that I need for my roof is 276 square meter by just creating a schedule for it. So that I can equally say that I can equally tell the client that we will need about 276 square meter for the roof. I don't need somebody to come from Domwood to come and climb my building and then do measurement and come and tell me that I need 276. The only thing that I will want to do that I'll calculate it and get 276. Then I'll let them come and also come and do their calculation. And when they come and tell me that the calculation for the roof is 350 square meter, then I can hold them on that, my friend, you are lying. Because when I did the computation on my machines, this is the value that I want. So if you call 3 vendors for each of them to bring you different roof quotation, you know who is doing the right work and who is not doing the right work. So please never underestimate the schedule, please. Never underestimate the schedules. It is a very handy tool that we are going to use as we move along. Any question again? Hello? Listen. Mr. Dixon. Mr. Benjamin. Benjamin.
Yes, sir.
I think you have a quantity surveying background.
Yes, please.
You have a quantity surveying background.
Yes, sir.
Assuming you can calculate a roof schedule like this one from a building and then doing manual takeoff, which one is better?
Sir, using the machine is even faster than doing it manually.
And doing manually. So if the machine can help you do your takeoffs, then why do you have to do manual takeoff? That's the issue. If the computer can do the takeoffs for you, then why do you have to do manual takeoff? And with the manual takeoff, you can make mistakes. But what the computer will give you will be accurate and detailed. So if I do my wall schedule, I can calculate the total area for all my walls. Or something. If I go to sorting and filter, I can go to by area. Area for the walls. Then go to OK. You see, I'll get all the areas for individual walls here. I'll get their total length also here. And if I want to calculate the total area for all the walls, I'll go to formatting, go to area, then I'll choose calculate totals, go to sorting, then choose grand totals, and then go to OK. As soon as I do that, so the building that I've created here, from the foundation to the roof, the total surface area for the walls is 526 square meters, period. And it is an accurate value. The computer cannot be wrong. If you are supposed to do this thing manually, manual takeoff, how long do you think it's going to take you before you get this total area? So these are some of the things I want you guys to begin to think about apart from the floor plan, sections and elevations, and then the 3D that you can get from the project, you can also compute everything you want to compute. Yes, I come in.
Sir, I want to ask. Right now, you have calculated. You've got the square meter of the block of the blocks that you need to build that 2 bedrooms.
Yes, sir.
You have got a square meter.
Yes, I've got it.
So if you know the number of blocks, sir, how will you do it?
If I want the number of blocks, I need to put it, I can put in a formula. If I know that 1 square meter, I must know 1 square meter, how many blocks they should take. So 1 square meter is supposed to take how many blocks? Do you have a fair idea?
No.
Meanwhile, you said.
I said no. I don't have any fair idea about that.
So properly, there's a formula that you can use to get 1 square meter. So assuming that 1 square meter is going to use say 11 blocks. I'm just assuming that 1 square meter is going to use 11 blocks. I can easily pick my calculator. You understand? And then multiply 5, 2, 6, multiply by what? 11. Equal to, then I'll get 5,786 what? Blocks. And I can tell the client that he said,
I thought having the square meter of the area of the blocks. Having a square meter. I thought the one let's say 1 block. You calculate you have the area of each one. Let's say you have 2 square meter for 1 block. You can divide that one to within the 5 or something. You can get the number of blocks.
That one is another topic for discussion. The people who do these quantities and surveying, the quantity surveyors, they know. The quantity surveyors know what 1 square meter of a block, the number of blocks it contains. So you can always get that value from them. Then you just multiply by it. And I can even put in a formula. I can even put a formula in the schedule here. And then use that formula to calculate the number of blocks. I can do that.
We haven't reached there now. So
no,
please let's
no, we haven't reached there. We are just at the beginning stage. But I just want to tell you the possibility that is available to us.
All right.
Listen. That is how powerful the Revit is. It is good for contractors. In the US, for instance, the major contractors even use the Revit more than the consulting firms because it can help them to do their computation, calculations, fabrication, and all those sort of things. Are you okay? Please, this is just an introductory class. I am just opening up to you the possibilities that we can achieve with it, okay?
Yeah.
Okay. Any question? If there are no questions, that's a good time to stop.
Okay.
Abeg.
Thank you, sir.
We are meeting tomorrow.
Yeah.
Let's meet Monday to Thursday so that we can finish early. You can
So are we adding Tuesday to it?
Yeah, I'm suggesting.
Okay.
So that we meet Mondays, Tuesday, Wednesdays, and Thursday. So that we can use that time to finish than going longer days.
Okay. Okay.
Good. So
That's cool.
8 o'clock.
Sure.
Thank you, sis.
All right.
Welcome.
Thank you so much.
You're welcome, sis. You're welcome, madams. Bye-bye.
Bye.